Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Zalfa Nurul and my friend usually call me Zalfa. I'm from the Department of Chemistry, Chemistry A, and Faculty of Science and Technology. And here I will explain about sampling strategy, analyte contamination, and reagent contamination. Okay, the first sampling strategy, water and wastewater analysis. What we can do is sampling. Sampling is collecting a certain volume of a body of water to be studied with the smallest possible amount but still representative and still has all the same characteristics as the water body. Okay, sampling is divided into three steps. One, representative sampling. Two, transport and sample preservation. And three, sample chemical analysis. Preparation for sampling and its preservation. Okay, the first, the bottles used to take samples must be clean and have been rinsed with distilled water first, then followed by the liquid that will be used to fill the water and dry, if possible. 2. Sampling tools such as pipes, pumps, etc. must be clean and free from residues from old samples, especially the growth of mold and mildew. And 3. Contamination from metals or sampling equipment which may dissolve in the sample must be prevented. And 4. Iron, brass, bronze can dissolve in acidic or alkaline water, while plastic and rubber materials can dissolve in industrial wastewater containing organic solvents or oil and gasoline. And 5. Samples can be taken separately using a bucket, plastic or glass bottle, open and weighed, for example with a lead ring around the neck tied with a rope, then put into rivers, canals, wells, and so on. Okay, next, how to take samples at a particular depth. The first, provide a closed bottle that can open when it reaches that desired depth. The second, another way is to use a kind of pump that sucks. The third, samples from tap water can be taken with an open beaker or a bottle to be closed, depending on the analysis plan. And then, automatic sampler. The special tool for successive sample returns consists of suction pipe. The depth of the sample return point is limited to about 5 m below the apparatus. The second, pump. The third, clock to control sampling frequency, and then tool for dividing samples into bottles for mixed samples, and then isothermic box containing bottles of mixed samples by cooling by ordinary ice or dry ice, so that sample preservation can be carried out at least 1 day before being brought to the laboratory. And then the sample should fill the collection vial completely, and the vial should be tightly closed to avoid contact with air. And then one common way of preserving samples is a cold atmosphere. That sample is transported in an isothermic contact containing ordinary ice or dry ice, CO2, and then stored in the refrigerator or freezer. And then interruptions that may occur during storage and sampling of samples. The first, gases such as oxygen and carbon dioxide, can be absorbed by the sample water or can disappear from the sample water into the air. And second, suspend and colloidal substances can form their own flux and precipitate, so that there are samples that are different from their original state. And then, at least the mood must be suspended again evenly before analysis and shaking the storage bottle. And then, like substances and liquids, such as mud, grease, oil, etc., can float on the surface. And then, some solutes can be oxidized by dissolved oxygen, turning into other compounds. For example, dissolved Mn2+ can be oxidized by oxygen to MnO2, which can precipitate and disappear from solution. And then the second is analyte contamination. Analyte is compound of materials the parameters we are studying and want to see the levels, and analyst is the person who measure it. Okay, contamination and loss in water analysis. Contamination is defined as the entry of unwanted compounds into the sample during the sample pretreatment process and during analysis. The source of contamination comes from atmosphere, operators, equipment, water, and reagents. The first, contamination from the atmosphere, primarily derived from particulate trace elements on the ground surface from materials suspended in the atmosphere. The simplest way to avoid atmospheric contamination of the sample is to cover the sample solution during the preparation and analysis process. The second, contamination by operator. The analysis can be a source of contamination of the sample to be analyzed either through direct contact or through the air. Natrium and chloride can transfer to the sample through the operator's breath. Dust and cigarette smoke are sources of metal contaminations. And then powders, lotions, perfumes, including operator clothing and shoes, also contain sources of contamination. Human skin is reported to contain metals even in very low concentrations. To reduce this contamination, we can use masks, gloves, and laboratory coats. And then contamination from equipment. 1. Glassware. 2. Glass in analytical chemistry means borosilicate glass, such as Pyrex, unless specifically stated. And then contamination of samples from glass is usually caused by attack dissolution of the container by the solution. Pyrex is resistant to weak acids and bases, but less resistant to strong acids and strong bases. For Se, silicon, and boron. Analysis using a Pyrex bottle. And then HSG, or high silica glass. Tip glass is more resistant to solution and heat attack up to 1900 Celsius. Washing glass were using a 1:1 mixture of concentrated H2SO4 and HNO3 is better than a mixture of Cr2O7 and H2SO4. In order to minimize contamination of the glass, the equipment should always be flushed and immersed in a dilute solution, at least 0.1 molar each HCl or HNO3 when not in use. HCl or HNO3 can be used to clean the glass surface from metals. And then, preparation equipment that is frequently used and has a lower probability of metal contamination. 1. Fused silica or quartz can be used at high temperatures and is safer from metal contamination. Possible contamination comes from materials absorbed by silica in previous use. 2. Plastics, polyethylene and polypropylene, resistant to attacks by most reagents used, not resistant to heat, contains additives, anti-oxidizer, UV absorber, and other compounds to assist mixing and fabrication. And 3. Teflon or tetrafluoroethylene polymer can be used for temperatures up to 300 Celsius, inert to almost all analytical reagents. And then PVC or polyvinyl chloride contains metals with high enough levels, for example, zinc 7 ppm, and then Fe 270 ppm, and then Sb 3 ppm, and then Cu 0.6 ppm, also reported to contain Pb, Sn, Cd, and Ti. 5. Rubber. It is recommended not to use rubber equipment in the trace analysis. Rubber contains several additives such as zinc oxide, antimony compounds, and Pb compounds. And then filter paper. Most filter papers contain a number of metals with varying content. And then contamination from water. Used in very large quantities compared to reagents, ratio 100, it is necessary to pay special attention to the purity of the water used, especially in the trace analysis. And then, to reduce metal contamination in water, the water needs to be passed first into the ion exchange resin pool, or at least 2 distillations are carried out. And then reagent contamination. Contamination in reagents can be grouped into 4, namely mineral acid and ammonia. The first, mineral acid and ammonia. Mineral acid must contain a certain amount of metals. Distinguish strata with extra pure acids containing metals in very low levels generally have a fairly expensive price. Ultra pure generally contains a very low metal concentration, but the contents of some elements varies per product. Analytical reagent grade acid usually contain metals. The acid used can be purified by distillation. And then ammonia. Ammonia solution in water placed in a glass bottle will be contaminated by silica, aluminum, calcium, and other elements which may be caused by the attack of the alkaline solution on the glass. An analytical reagent, ammonia, can contain heavy metals in a very low concentration. This may be due to the adsorption of these metals by glass. And the second, inorganic solid. The quality of the reagent is pure enough to be used direction without purification, but a blank solution is a control must be prepared. Purification is usually by crystallization or filtration. And then organic reagents from the reactants or compounds or materials used to react, usually containing a coordinately bonded metal. This metal is very reactive with metals, so anything around it can be bound to from a shielded. And the last, organic solvents. The content of metals and organic solvents is relatively low, so that the presence of other organic compounds interferes with the determination of spectrophotometric compounds. Analytical loss may occur due adsorption, volatilization, or precipitation. Okay, thank you. Maybe that's enough for me. I'm sorry if there was mispronounced from me. Wassalamualaikum warahmatullahi wabarakatuh.